So hello guys, today we are going to solve a Leetcode question that goes by the name find the integer added to array 1. Question number is 3131 and it's an easy question. It's a very easy question actually. But still we have to make a solution for this because there might be some people who might not understand the solution. Okay. What we'll do is we first try to read the problem statement and then we'll go on to the solution. Okay. So what are you given with this? You're given two arrays of equal lengths, nums1 and nums2. Each element in nums1 has been increased or decreased in the case of negative by an integer represented by the variable x. Okay, so it is given that, let me open Excalibur. Okay, so they are basically given two integer arrays, nums1 and nums2, and you are given with that each element in nums1, each element, that suppose these are some elements, so each element is increased by some number x, increased by number x. Okay, as a result nums1 becomes equal to nums2. Okay, so after increasing, okay, all the elements will become equal to nums2. Suppose it is x, y and z, three variables, then a, b and c, 3. Okay, so what I am saying is if I increase it by some arbitrary value, suppose I will increase it by k is equal to 2, so x plus 2, y plus 2 and z plus 2 will be equal to this a, b and c respectively. Basically x plus 2 would be equal to a, y plus 2 is equal to b, z plus 2 is equal to c. These might not be arranged in orders, but the number of total elements would be equal. Suppose basically if there is 1 to 3 and here it is 3, then 4, then 5. Okay, so you can just increase them by 2, so it is like 3, then 4, then 5, and it is also 3, 4, 5. So in this case, what is the value of x? Basically 2. So I have to find this x. That by what number all the elements must be increased, such that all the elements become equal to the second array. Okay, so the question might look a little difficult to understand. Okay, because they have given such a big problem statement for such a 3-liner question. Okay, so 3-liner question, or depends which technique you want to use. Okay, so what I'm going to say is basically each element in nums1 has been increased or decreased by an integer. Okay, nums1 becomes equal to nums2, or two arrays are considered equal when they contain the same integer with the same frequencies. Okay, return the integer x. So let me try test case 264 975. The first array consists of 264 and then 975. Okay, so I have to add some k value to this or x value to this. All the values of this array, all the integers of this array, I have to add this x value such that the overall resultant array is this. Okay, so what can be my approach? If I just try to compare every element with every element, basically this with this element, this with this element, this with this element, I cannot get a value of x, because I will have to just calculate for all the values, all the existing values that my x can range from. X can range from basically any value to 10,000, 10,000, any constraint that is given. So what I can do is, instead of traversing all the values from 1 to 1000, what I will do is simply, if I sort both the arrays, if I sort this array as well as if I sort this array, I'll get the sorted form. This sorted form becomes 2, 4, 6, and for this the sorted form becomes 5, 7 and 9. Okay, and if I just try to compare now my smallest elements, what is the difference between them? 3. What is the difference between them? 3. What is the difference between the second element? Is it 3? Yes. What is the difference between my third element? 3. Is it 3? Yes. So as you can see, the value of the k or x is equal to 3. So how did I get this intuition? Okay, how did I get this intuition? Basically see, if you just try to compare all of the elements with all of the elements, you will run into a time complexity of n square, n cube, or maybe if you try recursion, you will be in a big loop. Okay, so what I'll say is I have to organize the elements. I have to organize the elements in some way. Organize the elements in some way. So I thought of it like this. Uh, there must be some maximum and minimum elements, some maximum and minimum elements in both the array. So if I could access to any one of them of both the arrays, okay, suppose basically the minimum of one is x and minimum of y is, minimum of the second is, first array is x, second array is y. Okay, so if the condition holds, suppose x k is the k is the number by which we will increase every element. So for the minimum also, this condition would be holding. This condition would be holding. So I could simply, if x plus k is equal to y, then x should be equal to y minus k, or k is equal to y minus x. So what I'll simply do is, if I have to add something to it, I'll just take my x to the right side, make this equation, and compare my min or max elements, because the condition would be holding true for the min and the max elements also. Okay, I'll just try the second test case and you will get a better understanding, or the third test case, or I'll make a test case. Just leave it 3, 5, and then 7. Okay, and here it is like it is not 15. Okay, and here it is like 18, 6, and then 10. Okay, so I have to convert this to this. So what I'll do is I cannot just I can see that if I just try to rearrange the arrays 3, 7, and then 15, and for this 6, 10, and then 18, okay, the condition would be holding for the first element also, like for this element and this element. Okay, because there is no particular array, no particular element beyond this, before this. Okay, no particular element before this, and there is no particular element before this. So if I just try to add my k value to this, if I just try to add, so it should result in the first value only. It should result in the first value, because there is no case such that my value wouldn't exist. My value will always be existing. So the first element plus k should always match my middle, should always match my first element of this. Okay, so the first element from this, let us say a, first element from this, let us say b. So a plus x equal to b should always hold true. Okay, should always hold true. And if I take my a on the right hand side, so it would be like x is equal to b minus a, x equal to b minus a. Okay, so that's it. Okay, and I can do the same for the last also. You can check any of them, either the first element or the last element, or you can check the middle element also. Never mind, because the size would be the same. Size would be the same. Okay, it is convenient to check for the first and the last element. Okay, or you can just iterate. You can just iterate over both the arrays and get the minimum or the maximum value. I'll just use sorting because it is easy. Okay, easy to use. So easy to use and implement, obviously. So if I just take one more test case, suppose 3, 1, and 9, and you have to do this to 7, 5, and then 14. Okay, I'll just try to sort it 1, 3, and 9. I have to make it to sorted order 5, 7, 14. The first element plus some k value should be equal to this element, because it cannot exceed. Because there is no such condition that my element would not be following this condition. So this element 1 plus k should be equal to 5, and if I just rearrange, k would go here and k would be 4. If I just see, second element is matching, third element is also matching my condition. Okay, third element is also matching my condition. Basically this should be 13. Okay, we just try to code it for you. It is a very simple approach. See, nums1 dot begin, nums2 dot begin, then the same for the second array. Nums1 dot end, and then nums2 dot end, and then at last what you have to return, nums2 of 0 minus nums1 of 0. Why? Because see, this element would always be greater than this, the first element. This element would always be greater than the first element because this is something added, extra. Okay, I just try to run it. Okay, there's a typing error. I just try to run it. I'll try to submit. See, just 3 lines. It's very easy. Okay, but the time complexity is a little high because see, you are just sorting both the arrays first. Okay, so both of them would take n log n time, n log n plus n log n, and that's it. Okay, so 2 into n log n time you are taking. Also, you could reduce it by using two traversals following the O of n approach. O of n approach, you could get the minimum element out of both the arrays, minimum element of the first array, as well as the minimum element of the second array, and you can just subtract it. You can just subtract it to get your answer. Okay, so this was the solution. I'll attach the second code also in the description. Okay, so this, as I discussed about the time complexity is 2 into n log n. What is the space complexity? Am I using an extra space? No, space complexity is O of 1. This was the solution to the question, find the integer array, add it to array 1. Yes, it was a basic question, but still, some people might be there who wouldn't understand the solution. So that is why you have to add the solution. Okay, so okay, something new to learn for anyone. So this was the overall solution to the question. Find the integer array to add it to array 1. Add it to array 1. So if you guys didn't understand anything, you can just ping it out in the comments. Like the solution, do like, share, subscribe. Thank you. Have a nice day. Bye bye.